Hello, I am Mr. Henrik from Henrik Academy. Welcome back into my channel. In this video, I will explain how we doing a past paper 3 of physics, advanced practical class 1 on October-November 2022, past paper from Cambridge International AS&A level. Okay, let's start with the first experiment. So we may not need to use all the materials provided. But for the first experiment, we need paper. Okay. In this experiment, you will investigate oscillations of card shapes. So we need card paper. We have been provided with a circular card of radius 10 centimeters. So to reduce 10 centimeters, and then draw a circle on the card of radius 9 centimeters as shown in figure 1.1. So this is a card with your cut with scissors, and then set like this. The radius inside is 9 centimeters, so there is 1 centimeters for uh, the rest circle. Okay, the next step, fold the card in half. Okay, so this card fold, and then cut carefully along the line, along this line, and keep both parts of the card. So cut this, and we only need this part. Okay. Later we need the this remaining parts. Okay, but for the first step, we just need this one. Okay, and until becomes like this. After after we cut with the scissors, so we got the card. The card becomes like this. Okay, folded. So the distance between the center of one side of the card shape and the center of the other side, it's it is d or distance, okay, or diameter from this point to this point. Okay, this is the folded edge, and the cut shape. Okay, I think you understand this. Measure and record D. I have measured the record D based on my experiment, and it is for me 19 centimeters. Maybe if you will measuring your experiment, maybe you can get 20 centimeters or 18 centimeters or 18.5 or 19.5 based on your experiment. Standard cut shape on the bands. So provide a band like this. Recall that the distance between the card, this point and this point, okay, 3 centimeters. So after that, adjust the loops of the card until the distance between the points where the loops touch the bands is approximately 3 centimeters. So you can arrange 3 centimeters or 2.5 centimeters. But for me, I arrange 3 centimeters. The distance between this point into this point. And the next step, gently press. So we press to downwards, gently press down one side of the card shape through a short distance. Okay, so press down, press to this one for example, this part, this side, through a short distance, release the card shape so that is oscillates. So oscillations happening if the positions when we gently press from these positions from, for example, from zero to from from O to P. Okay, the first position is O when we press until press down until P, and oscillations happening when we press, and it will be returned to the first position P to O. That's oscillation one oscillation. Determine the period of these oscillations. Right. I have tried two experiment 2 times gently press downwards. So the first the first experiment I got frequency for 7 of 10. Okay. Because for frequency formula n over t. This is time, and n uh, how many uh, how many oscillations happening. So I got 7 as long as t seconds. There are 7 oscillations. And the second, I got frequency same 7/10. So it will be 0.7 second. And sorry, I mean this is period. Uh, sorry. Okay, for the first is 7. The frequency is 2. Okay, 2 hertz, as well as second frequency 2 hertz. Okay, and it means the period. The first period is 7/10. 7/10. Okay, and this one as well, 7/10. Right. So the period is 7/10 is 0.7. Of course, second. And next, for the next step, use the remaining card to cut out shapes of smaller radius, each with the same width of 1 centimeters. So we're gonna cut this remaining card. It's now this one, this part. Okay, this one. When we just now we didn't use this part, and now we're going to using that part. Okay. So we cut same with the previous one. Okay, this is 1 centimeters, 1 centimeters. Okay, just now this is the diameter. The diameter after we cut is, if not mistaken, 19 centimeters. Just now this 19 centimeters. This one, 19 centimeters. So now we cut this area, and this 1 centimeters. 1 centimeter, it means 19 minus 1, and it will be 17. So record your result in table includes values of the square in your table. So D in centimeters, so that T in second, and then T squared, of course, second squared. So 17 centimeters, okay? And through an experiment, I got as well 0.7, the period second, and T squared, it means 0.49 second squared. And according to this information that for each card shape, measure D and repeat. Okay, ready? Repeat until you have 5 sets of values of D and T. Okay. So this is the remaining is 15. Of course, if we cut, so it's going to be 15. So 15, after that is 15. Again, we're going to cut 1 centimeters, 1 centimeters, so 15. When if 15 through my experimental, it's going to be, the period is 0.6 second. So T squared 0.36 second squared. And next, 13, I will report my experiment. Okay, 0.25, 1 to 3, and according to this information, we have to set until 5. So after that, 11, and if 11, 0.4 means 0.16, and 9, the last one, 0.4, according to my experimental, 0.16. Okay, so this is the table, the result, my experimental result. I don't know if you would like to create your experimental. Maybe you can have the different results. Next, plot a graph of the square on y-axis against D on the x-axis. Okay, so on the x-axis is D and y-axis is the square. Draw the straight line of best fit. Determine the gradient and y-intercept of this line. Okay. Okay, I'm going to using this point. 13, D equals 13, and T squared 0.25. Okay, D equals 13, and T squared equals 0.25. I'm going to using an equations according to mathematical formula that y minus y1 equals m multiply x minus x1. Okay. For the gradient, we can determine the gradient y over x, so it means 0.49 over 17. We can determine the gradient is 0.49 over 17, and the result is 0.0288. That's the gradient. So we can substitute here. y minus y1 is, so this is y-axis, this is x-axis, 0.25, 0 point m is 0.0288 multiply x, x1 is 13. So it's going to be y uh, if you expand, it's going to be y equals 0.0288x plus 0.25 minus 0.3744. 0.3744 from this one because 0.0288 multiply 13. So it becomes the equations, sorry, not y, but t squared. Okay, t squared equals 0.0288 d minus 0.1244. Okay. Now, y-intercept happening if d equals 0. If d equals 0, we can find the y-intercept. If d equals 0, if d equals 0, it means y-intercept is 1. Okay. Minus 0.1244. Next, we're going to sketch. I'm going to using this, okay, this part. Okay. Select this one. Okay, and then afterwards, this is the, sorry. I'm going to sketch the x-axis or the axis. Okay, this is the axis, and this is the squared axis. We're going to start from 0. 0.49 and 17. 17 and 0.49. If 0.5 here, okay, 0.5, 0. If 0.5, it means 0.4, or here 0.3, 0.2, oh, 0.2, and then 0.1 here, 0.1, and 0 here. Okay. Sorry. Okay, so the origin will be here, and this is the d-axis. Okay. Now 0.17. So 17, for example, if 17 here, 17, and then 15, sorry, one, yeah, or else 13, or else 11 and 9. 11 here, okay. If we create the graph, later you can create with yourself. The graph will be 9 here, sorry, 17 here, so 17 and 0.49 around here. This is 17, 0.49. This is 0.5. And then 15 here, 0.36. 0.4, 0.3. After 0.49, 0.36 around here. Okay. 16 and 15, sorry, 15 and 0.36. Want to check? Oh, correct. And yeah, this is 17, this is 15, 13, 11, 9. 13 and 0.25, this is 0.1, 0.225 around here, and 13. 11 and 0.16, 11 and 0.16, 11 and 0.6 around here. Then 9 and 0.16 as well. 9 and 0.1. Yeah, 0.16 around this around here. So, but we can find connecting all coordinate point like this. It's a straight line. So please check again your result regarding regarding 9. So 9 because later on the strike line will be uh yeah will be intercept where we have intercept point on origin, because if d equals 0, if diameter equals 0, of course t squared equals 0. But I would like to tell you that the graph is a straight line graph. Okay, next. It is suggested that the quantities t and b are related by the equation t squared equals ad plus b, where a and b are constant. Using your answer in part D3, determine the values of a and b, give appropriate units. So now our expressions, our equation is t squared equals 0.0288d minus 0.1244. So the implication, coefficients of A is coefficients of D, and this is B. So A equals 0.0288, while B equals minus 0.1244. Theory suggests that A equals to pi squared over G, where G is the acceleration of free fall. Use your value of A in E to determine a value for G given appropriate unit. Okay, so it means G based on this, if we create G being the variable which we want to find the result. So G, if G the subject, so it will be 2 pi squared over A. So it means 2 multiplied 3.14 squared over A equals 0.0288. I have calculated, and the result is 684.694 centimeters per second. Number two, in this experiment, you will investigate the collisions of two pendulums. To A, to A1, two pieces of modeling clay onto the ends of the shorter strings to make two pendulums, as shown in figure 2.1. This. Okay. Set up the apparatus as shown in figure 2.2. This is the apparatus. Okay. These are two pendulums. Okay. With clay. And next, adjust the modeling clay until the lengths of the pendulums are the same. The distance between the bottom of the wooden blocks and the center of the smaller piece of modeling clay is L. Okay, so I'm going to show you this is L, this one. The center of pendulum and the block, as shown in figure 2.2. Measure and record L. So for the length of the string, I use 20 centimeters. Okay, 20 centimeter string. Hold the larger pendulum a short distance away from the smaller pendulum, as shown in figure 2.2. So when you will create this experiment, so set like this is the first, the smaller pendulum, and this is the bigger pendulum. So set until their position like this. For me, I have determined P. The horizontal distance between the centers of the pendulum is P. Okay, that the distance. Okay, horizontal distance. Hold the larger pendulum. So hold the position like this, and after that, measuring P. Okay, measure and record P. I have record P. P is 12 centimeters. Calculate R, where this is the formula, R equals square root 1 minus P squared over L squared. So R will be square root 1 minus 12 squared over 20 squared. And it is square root 0.64. It is 0.8. So 0.8, of course, centimeters. Justify the number of significant figures that you have given for your value of R. So this is 0.8, one significant figure. Okay. Hold the larger pendulum so the horizontally distance between the centers of the pendulum is P. Okay. Release the larger pendulum so that the pendulums collide. So it will be collide, the larger pendulum and the smaller pendulum. After colliding, the maximum angle between the vertical and the string of the smaller pendulum is theta. So this is theta. Okay. Measure and record theta. Okay, I have record theta, and theta is I have measured theta based on a protector, and theta is 33.37. Next, estimate the percentage uncertainty in your value of theta. Show your working. Okay. So the percentage uncertainty is at 33.37 plus minus 0.1 multiply half. So it's going to be 33.37 plus minus this is 0.05. This. Remove the modeling clay from the strings. Repeat A and C using the longer strings. Okay, so I have used the string 30 centimeters and P still 12 centimeters. Okay, so R would be, I have calculated R, the root 1 minus 12 squared over 30 squared. It is square root 0.84. The result is 0.92. And yeah, this is 0.92, and theta, based on my measurement, theta is 22 degrees, right? It is suggested that the relationship between theta and r is k multiply 1 minus cosine theta equals 1 minus r, where k is a constant. Using your data, calculate two values of k, right? So we can arrange this formula. If k is the subject, so 1 minus r over 1 minus cosine theta, right? Recall that theta is 22 theta, 22, so we can determine theta. 1 minus r is 0.92 over 1 minus cosine 22. So I have calculated this. K equals 1.096. The first value of k is, before approximation, that 1.095890, and the second values of k is 1.096. It suggested that the percentage uncertainty in the values of k is 10%. Using this uncertainty, explain whether your result support the relationship in E. Okay. So if 10%, it means 10%, or 0.01 multiply half is going to be 0.005. So the uncertainty result will be 1.096 plus minus 0.005. And uh, you can calculate, you can find the relationship with this number, this result. Next, G, describe four sources of uncertainty or limitations of the procedure for this experiment. For any uncertainties in measurement that you describe, you should state the quantity being measured and a reason for the uncertainty. Okay. One is, sometimes if we using two readings, If we did two readings, that is are not enough. Yeah. And that are not enough for taking the conclusion or for create the conclusions about uh, this experiment. And the second is we have a difficulty how to measuring L or length of string. Why? Because the locations of pendulum center. Okay, if this is a string and the pendulum like this, sometimes uh, we confuse which one the precise center of this pendulum. Okay, whether here or we have to know the precise information, the precise strategy, how to determine yeah, which area is the center of this pendulum. And the third is of course a difficulty uh, to determine angle. Okay, angle. Yeah, because of protector. Because of because of yeah, because type of protector. Okay, number four. What else? A difficulty. Okay, a difficulty to determine to determine L already or to determine P. Okay, to the to determine P. Okay, just now we determine P. Okay, the problem is again the locations of the center. So which area the precise center of the pendulum. We determine P because of the center because of center center uh, of clay or of pendulum. Describe for improvements. Okay, that could be made to this experiment. You may suggest the use of other apparatus. Okay, number one, yeah, we have to take more readings. It means we have to create more experiments implicated to more readings. Number two, improve the method to measure L. Okay, to measure L. For example, add a pointer. Okay, add a pointer uh, on the pendulum, so we can make sure that this is the pointer, this is the center. So the pointer is the center of pendulum or the center of clay. Okay. Number three, improve the method to measure P. Uh, improve the method to measure I'm gonna check number three. Okay, to measure angle. Measure angle. Okay. It means we need because I use a different protector. Maybe for me, yeah, I need a clamp protector. A clamp protector. Okay. And number four, uh, improve a method. Improve the method to determine P. Okay. Improve. Again, we need add a pointer. Okay. So if we have pointer on a pendulum or at clay, we can make sure, we can ensure which one, which area is the center of pendulum or the center of the clay. Okay, students, perhaps this video useful for you and help you uh, uh, to prepare for your next examinations, for your next experiment. Thank you for joining with me in this lesson. See you